Okay, continuing in section 3, page 2 of the notes, a little bit of recall, which I've always said that when a math instructor uses that terminology, recall, they're saying, hey, if you don't remember it from the first time, learn this quickly. This is something you need to have ready to go in your brain. You get a same line or parallel lines or intersecting lines when you are solving a system of equation. The same line means that you end up with a true statement as you are solving, and it's a situation where you can say there's an infinite number of solutions, and it has the fancy vocabulary of being called a dependent system. Parallel lines is when you're solving and you get a false statement. An example of a true statement for a same line would be like 7 equals 7 or 0 equals 0. For parallel lines, a false statement might be 5 equals negative 2 or 0 equals 3, something that's false, it's not true. In that case, you'll get no solution, or you can write it as the circle with the slash through it, and it's known as an inconsistent system. Or the lines intersect where you get 1 point, 1 solution. It's the point of intersection of the two lines, and that is known as a consistent system. Okay. And these terms are discussed on pages 294 and 295 in the book. Let's try an example, page 316, number 36. And the steps actually should show up on your notes. The particular copy I printed out here don't have them, so let's just rewrite those really quick. The steps here, they should be on your notes. Hopefully I loaded a copy for you that had these. You need to rearrange to standard form. The goal then is to multiply one or both equations by whatever it takes to get equal but opposite coefficients of whichever variable you want to eliminate. Equal and opposite coefficients of the variable you want to eliminate. Then you'll add the two equations together. You'll solve for the variable that didn't get eliminated. You'll use back substitution, which we got really good at, pardon me, in 5.2 when we were using the substitution method. And then of course you will check in both equations. So in this case, I've got 2x minus 5y equals negative 1, 2x minus y equals 1 is the second equation. I've got matching coefficients. I just need one to be positive, one to be negative. So I'm so close to having it here. I'm going to take that top equation, multiply by negative 1, and step 1 was already done for us. They were both written in standard form to begin with. Multiply the top equation by negative 1 all the way through. I get negative 2x plus 5y equals a positive 1. Bottom equation stays as is, 2x minus y equals 1. And that's step 2. Step 3 then says to add them together. And when I do, the x's fall out. That's the whole point of the addition method, to eliminate one of the variables. So 0x, 5y minus 1y, or just minus 1y, is a plus 4y, equals 1 plus 1 is 2. So that leaves me with 4y equals 2. Divide both sides by 4 and reduce. I get y is equal to positive 1/2. Then I can use back substitution. So this right here was step 4. Then I can use back substitution, pull either equation here, 2x minus y equals 1. Back substitute our answer in and get 2x minus 1/2 equals 1. Add 1/2 to both sides, I get 2x is equal to 3/2. Divide both sides by 2, I get x is equal to 3/4. Again, if you're having trouble with fractions, let's get some help right away, because that's really a Math 20 topic I know a lot of people struggle with, but it is possible to get better at fractions. You just need lots and lots of practice and starting to talk it through and make it make sense for yourself. So we check those in both equations, and they do work in both. And then our solution set is parentheses 3/4, 1/2, and of course written in the braces.